Have you ever wondered how your car engine actually works? How does fuel turn into the power that moves your vehicle? In this video, I'll explain the complete four-stroke engine cycle with detailed animations so you can understand exactly what happens inside your engine. I'm Mohammed Wasim, certified mechanic from New Tech University, and welcome to Mahar G Autos, where we master complete automotive systems. By the end of this video, you'll understand all four strokes: intake, compression, power, and exhaust. Let's dive in. First, let's understand the basics. A four-stroke engine is called four-stroke because it completes four distinct movements, or strokes, to produce power. These four strokes happen inside the engine cylinder. The main components involved are the piston, which moves up and down inside the cylinder; the crankshaft, which converts the piston's up-down motion into rotational motion; the camshaft, which controls the opening and closing of valves; the intake valve, which allows air and fuel mixture to enter; and the exhaust valve, which lets burnt gases exit. Now, let's see how these components work together through the four strokes. Stroke number 1, the intake stroke. During the intake stroke, the piston moves downward from the top of the cylinder to the bottom. As the piston moves down, it creates a vacuum, a low-pressure area inside the cylinder. At the same time, the camshaft opens the intake valve. Because of the vacuum created by the descending piston, the air-fuel mixture is sucked into the cylinder through the open intake valve. In a petrol engine, this mixture is created by the fuel injection system, or carburetor, which combines gasoline with air in the perfect ratio, typically 14.7 parts air to 1 part fuel. The exhaust valve remains closed during this stroke to prevent the mixture from escaping. By the end of the intake stroke, the cylinder is filled with the air-fuel mixture, and the piston is at the bottom position, called bottom dead center, or BDC. Stroke number 2, the compression stroke. Now both valves close. The intake valve and the exhaust valve are sealed shut. This is crucial because we need to compress the mixture. The piston begins moving upward from the bottom to the top of the cylinder. As it moves up, it compresses the air-fuel mixture into a much smaller space. This compression is extremely important. Why? Because compressing the mixture serves three purposes. First, it increases the pressure, which means more force when ignition happens. Second, it increases the temperature of the mixture, making ignition easier and more efficient. Third, it ensures complete burning of the fuel. The compression ratio in most engines is between 8:1 to 12:1. This means the mixture is compressed to 1/8 or 1/12 of its original volume. At the end of the compression stroke, the piston reaches the top position, called top dead center, or TDC. The mixture is now highly compressed, hot, and ready for ignition. Stroke number 3, the power stroke. This is where the magic happens. Just as the piston reaches top dead center, the spark plug fires. In a petrol engine, the spark plug creates a high-voltage electric spark that ignites the compressed air-fuel mixture. The ignition causes a rapid, controlled explosion. This explosion releases enormous energy in the form of heat and expanding gases. The pressure inside the cylinder can reach 1,000 pounds per square inch or more. This high-pressure gas pushes the piston downward with tremendous force. This is the only stroke that produces power. The other three strokes are preparation for this moment. As the piston is pushed down, it turns the crankshaft through the connecting rod. The crankshaft then transfers this rotational energy to the transmission and ultimately to the wheels, moving your car forward. Both valves remain closed during the power stroke to contain all that energy and maximize the force on the piston. Stroke number 4, the exhaust stroke. After the power stroke, the cylinder is filled with burnt gases, the byproducts of combustion. These gases need to be expelled before the cycle can start again. The exhaust valve now opens. The piston, using momentum from the crankshaft and other cylinders, moves upward again. As it moves up, it pushes the burnt gases out through the open exhaust valve. These gases travel through the exhaust manifold, then through the catalytic converter, which cleans them, through the muffler, which reduces noise, and finally exit through the tailpipe.
By the time the piston reaches top dead center again, most of the exhaust gases have been expelled. The exhaust valve closes, the intake valve opens, and the cycle starts over with a new intake stroke. This entire four-stroke cycle happens incredibly fast. In an engine running at 3,000 RPM, each cylinder completes 1,500 complete four-stroke cycles every minute. That's 25 complete cycles every second.
It is a complete procedure of four-stroke engine. Like and subscribe to my channel for more videos in vehicles.